The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, ladies and gentlemen. Welcome to TechGig webinar series, our endeavor to empower techies. We believe that sharing of knowledge is the key to enhance our skills and grow us as professionals. With this principle in mind, we have initiated a series of webinars conducted by industry experts to give you all a crisp insight of various domains. The topic of today's session is Microsoft SQL Server 2014 in-memory OLTP. Our guest speaker today is Amit Govil. He's a test consultant at Microsoft India. He is professional with over 7 years of experience in architecture design, deployment, and troubleshooting of SQL Server. He has been with Microsoft for almost more than 2 years now. He is also a clean planner with expertise in training and handling pre-sales with partners and field engineers. He has hands-on experience on almost all the versions of SQL Server 2000 to 2014. He specializes on SQL Server infrastructure planning, designing high availability and disaster recovery solutions, and performance tuning, to name a few areas. His certification includes MCSA SQL Server 2012, Microsoft Certified Technology Specialist SQL Server 2005. He works on various domains, but his expertise is on healthcare. So without further delay, I introduce you all to our guest speaker. Over to you, Amit.
Hi, thank you, Aradhana. Thanks for the introduction. Hello, everyone. Very good afternoon. Right. So I think we are all set. So in this session, we'll take a closer look at the unique design patterns of Microsoft SQL Server's in-memory solution, right? And the kind of impact or what would be the significance of those impacts that it can have probably on your business, all right? So let's move further. Right, so the deck that you see right now on your screen is, or I should say they are probably the various buckets wherein we saw most of the investments going in with the release of 2014, which got released in early April this year. All right, so the first one being the in-memory technologies. Now out of this, the first one, as you see on the screen, is the in-memory OLTP. That's the major chunk of area that we're going to talk about today, right? In there you also see the in-memory data warehouse, right? So wherein you have the updatable column storing indexes, right? That's an enhancement with 2014, because in 2012 you had the non-clustered column store indexes which were not updatable, but then the engineering teams have worked significantly harder and they came up with the updatable column store indexes to kind of overcome the shortcomings that it had, right? But there is also an extension to the buffer pool, so you can have your buffer pool extended now on the SSDs, right? Just in case you want to enhance further performance of your SQL Server by extending the buffer pool, right? So that's one area. On the second stack, as you see, there are certain enhancements towards the high availability side of things as well. So there have been some enhancements towards always on, then the online database operations and also, right? Then a lot of emphasis is going on towards the public cloud side of things as well. So Microsoft has Azure, which is the public cloud offering from Microsoft, right? So SQL Server is now, SQL Server 2014, if I were to say, works very closely with Azure, right? So you can actually offload your backups and, you can even move your databases onto Azure. So a couple of enhancements towards that stack as well, right? And there are other investments as well in terms of Power View and all, which is definitely an area under the business intelligence side of things, right? So great. So let's move further. Now let's take a closer look on this slide as to how we as a Microsoft can impact your business with our in-memory technology, right? So just to let you know that Microsoft is the only provider till date that can actually speed your transactions as well as queries, and and the insights that it provides with the in-memory technology that it has to offer, right, for each of your workload. So as you see on the first stack, on the left hand side for the in-memory OLTP, with this particular feature, which got released with 2014, we have seen customers who have gained the performance improvement of up to 30 times faster transaction processing, right? So when I say so, I'm not talking about query speed, okay, but actually the transaction write speed, right, which has come out to be up to 30 times faster with certain of our customers. Now, when I say so, I know many of you might be thinking like our competitors like Oracle and other database vendors, they are offering about 100 times of performance improvement, right? Well, what they are talking about is query speed and not transactional speed, right? So when we say that we are offering you 30 times faster performance improvement, that is towards the transaction processing, right? Moreover, Microsoft is the only vendor that delivers an in-memory engine designed for OLTP transaction performance increase, right? Moreover, it actually integrates with your existing architecture. So there is no such dedicated appliance that you need to buy, or there are no significant capital expenditures that you need to do. All in all, it gives you these sort of performances on your existing hardware, right? It is just that you need to have the right amount of memory on your server. Now, on the second stack, as I said, there's also built-in memory column store indexes for data warehousing workloads to speed up queries. And on the last stack, you see that we also offer business users the ability to analyze the data and data models, right, in a much faster way with some built-in memory capabilities like Excel, which offers Power Pivot and Power View capabilities, right? So yeah, right. So with that, let's move further. Right. Now, a question that might come to your mind is, why would you need an in-memory OLTP, right? So just to let you know that the in-memory OLTP was formerly also known as Hackathon. This code named Hackathon was arrived from a Greek word, right, for the numeric value 100, because it actually represented the Microsoft's goal of improving performance by up to 100 times, right? So that's how it got its code name as Hackathon. Now, in traditional SQL Server database engine, right? So if you talk about, let's say, be it SQL Server 2005, 2008, 2008 R2, 2012, whatever, right? So in all the previous versions of SQL, right, the database engine was originally designed at a time when it could be assumed that the main memory was very expensive, right? It's still very expensive, but not compared to the way it used to be, in early 2000 days. So because of this, the data needed to be residing on the disk, right, except when it was actually needed for processing, right? So what I mean to say is that your data was residing on the hard drive, and whenever there were queries that kind of needed to read that data got loaded into your memory, right? So that was the architecture that SQL Server has been following till now. Now, this assumption is no longer valid because the memory prices have dropped enormously over the last 30 years, right? And at the same time, there are multi-core servers which are now becoming more affordable, right? And if I were to give you an example, you can actually go ahead and buy a server with about 32 cores and about 1 terabytes of memory for somewhere under 50,000 US dollars, right? So which is pretty cheap now. Now, the lock-free design that the in-memory OLTP feature offers is one of the key points that differentiates this particular feature from the rest of the database engine, right? Also, to let you know, it uses a new optimistic multi-version concurrency control mechanism in conjunction with algorithms that have been optimized for memory resident data. So we are going to talk a little more about this in the future slides, but in this particular slide, I'm just kind of giving you a glimpse as to what it is all about. Also, there is something called as natively compiled stored procedures. So the best execution performance, if you have to obtain the best execution performance, that is obtained when you use these natively compiled stored procedures with these memory optimized tables. So there is a demo lined up as well. So when we jump onto the demo, I think things would be more clearer to you, right? And these natively compiled stored procedures are actually stored as DLLs, which contain the machine code, and that's the reason you get even better performance every time you use them. All right. Let's move to the next slide. Now, before we jump on to the Microsoft's in-memory engineering design points, on this deck, let's take a look at a couple of key trends that have impacted our design. Now, as I said, one of course is the significant drop in the memory pricing that makes the in-memory databases feasible for customers. And the second is definitely around CPU performance flattening out, right? And when I say that, what I mean is that just throwing more compute power at a problem may not resolve the performance bottlenecks of your SQL Server, right? So with Microsoft, the in-memory OLTP, we have taken into account as to how do we go about better utilizing the existing CPU capacity that we might have at the servers, right? And yeah, so that's what predominantly what we're using it, right? Let's move to the next deck. Now, in this particular deck, you can see that by taking the advantage of the modern hardware trends, we are enabling the new applications, with high real-time processing threats, and since the addressable market size is also increasing, so that's the kind of direction that we are heading to. So if you see on the deck on the at the lower bottom, right? So you see that the memory prices, they are declining steadily. Also, the CPU power or the CPU clock rate, I should say, that's getting stalled over a period of time. And since you have multi-core processors available, so these are basically the driving factors behind this in-memory OLTP. On the second stack, or on the second horizontal stack, you can see that what are the main components of the in-memory OLTP architecture. You have the in-memory optimized data, right? You have indexes of two different types. We are going to talk about it shortly as well, right? There is no buffer pool sort of thing. It's all using B-tree structures. Sorry, no buffer pool or B-tree structures. It's rather it's just the pointers that it uses to kind of form a table. It's a linked list sort of thing, right? Also, you have T-SQL compiled to machine code. So this is nothing but the native T-SQL that I spoke about a while back, right? And as a result of which it does not needs to be recompiled each and every time it executes, right? Every time a SQL server is restarted, these DLLs for your machine code are loaded into the engine, right? Also, it gives you a lock-free and a latch-free environment. So there is high amount of concurrency, and that is actually achieved using a multi-version optimistic concurrency control. And also to let you know that though it is an in-memory data and you have multi-version optimistic concurrency control, but that does not mean that we are not following the asset properties, right? I hope every one of you understand asset properties, right? For a database to be a relational database management system, it has to follow all the asset properties. Asset is atomic, C is consistency, I is isolation, and D is durability, right? So even though we are working on in-memory data, that the data is totally durable, and it's highly transactional, right? And it persists forever, unless you have an option enabled wherein you can actually have non-durable non-durable memory optimized tables as well. So we are going to see that in the syntax. Now, as I said, there are no locks, there are no lock managers, no heavy locks, no heavy latches, right? So I'm not saying that there are no locks at all. Locks are there, right? But as in, we do not have any heavy locking, right, when we are talking about in-memory OLTP. So we'll see that in action in the demo. Last but not the least, this is the most important area, right? Because when the customers want to move to SQL 2014, right, that does not mean that they will have to kind of move their entire application or migrate their entire application, right? It offers seamless integration with your existing SQL Server architecture. So as in when we talk about the SQL 2014 in-memory OLTP, though it is a separate database engine, but it is actually offered with the traditional database engine capabilities that SQL Server has been offering in the past, right? So you just install things the way you have been doing till SQL 2012, and it is just that you need to kind of enable certain tables as in-memory tables, right? The tables that are used most in your environment, right? Or heavy workload tables, right? And you're good to go. Now, as a result of this, on the topmost, you see that there are definitely a lot of benefits associated with this. So you have high performance data operations, you have efficient business logic processing, you have frictionless scale up, and you have hybrid engine and integrated experience. Right. So on this particular deck, as I said, it helps you increase both the transactional speed and the throughput by removing the contention in the database, right? Also, in addition to speed, we also improved throughput because our engineering teams actually came up with an algorithm to remove the locks and latches without compromising on the durability, right? Which I already mentioned to you in the previous deck. Now, what this means is it kind of helps you in massive reduction of contention in the database, which leads to increased throughput as well as the high speed. Now, on the top corner, you can see, sorry, on the bottom left corner, you can see that there are certain case studies associated with it as well. You see the bwin.com, right? So bwin is actually an ISV in the online gaming industry, and for them, transaction equates to the revenue that they generate, right? So meaning the more amount of transactions that they are able to sustain with their application, the better is their revenue, right? So with this in-memory OLTP design point of optimized table structures, they were actually able to improve their transactional speeds by almost 16 times, and thereby they could actually increase their player capacity by about 20 times on the same hardware, right? Now, since the contention got significantly reduced, they were also able to cut the player response times by about 50 milliseconds to 3 milliseconds, right? So that's a huge reduction in terms of the wait that the player had to kind of face, right? So that was the kind of performance improvement that bwin got, right? Now let's move further and see. Now, when we're talking about in-memory OLTP, there are certain terminologies or certain terms that are associated to it that you need to be aware of, right? The first one being memory optimized tables. So when I say memory optimized tables, what I'm referring to is the tables which are going to use the new data structures, right, which are added as a part of an in-memory OLTP. Next is disk-based tables. So when I say disk-based tables, I'm referring to the alternatives to memory optimized tables, or I should say the tables that we have been using in the past, the traditional or the normal disk-based tables that we have been using in SQL, right? So those are called as disk-based tables. It is just that, you know, it is done to just ensure that we are able to differentiate between the memory optimized tables and disk-based tables, right? Now, in disk-based tables, as most of you would be aware, it has got pages of 8K, right? And you know, that needs to be read from the disk and written back to the disk as a unit. Next is natively compiled stored procedures. So again, I already mentioned about this. This refers to an object type which is supported by only in-memory OLTP or only in-memory tables, I should say, right? And this is compiled to the machine code, and this basically has the potential to increase the performance even further, right? Because you know, it kind of helps you improve your performance if you kind of use them with your memory optimized tables. So the idea is that you have in-memory tables and you have disk-based tables. So if you're using natively compiled stored procedures, those stored procedures could only operate upon disk-based tables. They cannot operate with the traditional disk-based tables, right? Next is cross-container transactions. Cross-container transactions are those transactions which could refer both memory optimized tables and disk-based tables. Then there is definitely interop. Now this refers to the interpreted T-SQL that could refer both your in-memory table and your disk-based table. Okay. So this is how the typical in-memory OLTP architecture looks like, right? So here we are looking at the overview of how in-memory OLTP operations and data are handled differently than the disk-based operations and the data in SQL Server, right? Now, during most of your data processing operations with in-memory OLTP, you might be unaware that you are working with memory optimized tables rather than just disk-based tables, right? So the working is so transparent, it is so seamless, right? However, behind the scenes, SQL Server works with your data very differently if it is stored as a memory optimized table, right? So although the in-memory OLTP is integrated with SQL Server relational engine and can be accessed using the same interfaces transparently, the internal behavior and the capabilities are very different, right? Now, in this particular diagram, as you can see on your screens right now, you can notice that the client applications are still connecting to the TDS handler the same way for the memory optimized tables as they are doing for the disk-based tables, right? Now, on the left-hand side, you see that there are natively compiled stored procedures and schemas, right? So, as you see, natively compiled stored procedures and schemas could only interact with memory optimized tables and indexes, and they cannot actually interact with the traditional tables and indexes on the right-hand side, right? Whereas if you see the interpreted T-SQL query execution on the right-hand side, it is basically capable of interacting with both the disk-based tables as well as the memory optimized tables. All right. So with that, let's move further. So again, on this particular screen, it kind of, as I said, the in-memory OLTP engine uses a new optimistic multi-vision control mechanism in conjunction with other algorithms that have been optimized for the memory resident data, right? And just to let you know that whenever a row is in a row in a shared buffer is modified, the in-memory OLTP engine makes an entry into the new version of that row and timestamps it, right? And this process is very fast because this entire thing is kind of going about only in memory, right? Now, the engine then kind of analyzes and validates any updated rows before actually committing them, right? And this design is faster and more scalable than the traditional locking mechanism that we have been using in SQL Server's relational database engine in the past, because there are no locks or other wait stats that would prevent the processor from running at full speed. Now, because this optimistic processing creates a lot of different row version, it is kind of imperative for you to leave a number of discarded rows in the memory, right? So, or I should say, because of this, certain discarded rows are kind of left into the memory, right? Now, to handle these discarded row versions, Microsoft actually implemented a new lock-free garbage collection process as a part of the in-memory OLTP engine, right? Which kind of processes and periodically cleans up all the unneeded rows, right? So that you can use your RAM, or you can use your memory in a more efficient way. Let's move further. So this particular deck shares like what should be the syntax when you are kind of creating your table as an in-memory table, right? So as you see, there has to be a primary key non-clustered hash index defined. That's the most important thing, right? Without a non-clustered hash index, you cannot create a memory optimized table, right? Also, if you see that there is a bucket count listed with that, right? Now, this bucket count is the number of distinct values that you are storing in the hash index, right? With some additional free space, so that you are on the safer side. So you need to make sure that you do not choose a very high number for this bucket count, because if you do that, you are actually wasting up on your memory, right? Also, you should ensure that you are not choosing a very small value for your bucket size, because if you do that, your performance is going to degrade, right? So the idea is that ideally or typically the bucket size should be almost twice the actual number of records in your memory optimized table. All right, so somewhere around that. Now, also a very important thing to let you know that with the initial release of the SQL 2014, you cannot actually resize the bucket count once you have defined. And if you want to do that, you will have to drop and recreate the entire index, right? Meaning the entire table. So as you see, there is a last option, memory optimized equal to on, which kind of ensures that this is a memory resident table, right? And also, if you say durability equal to schema and data, this ensures that your entire table is transactionally consistent and it's kind of durable. All right. Great. So let's move further. Now, this particular deck lists out that there are two types of indexes, which we just saw in one of the examples that was there on the previous slide. So as you would be expecting, indexes for memory resident tables are typically very different, right? So they don't use the typical B tree structures which are used by the on-disk indexes, right? So as you see on the screen, SQL 2014 uses either the new non-clustered hash indexes or memory optimized non-clustered indexes for memory optimized tables. So these are the two types of indexes that you can have on your memory optimized tables. Now, hash indexes are efficient for item lookups, but they don't perform the best, or I should say they don't yield the best performance for range values, right? So memory optimized non-clustered indexes are the best when it comes to retrieving range of values, right? They also support retrieving the table rows in the order that was specified when the index was actually created. Now also, Each memory optimized table, as I said, must have at least one index defined, right? And memory optimized indexes must be created as a part of the create table statement itself, right? So it's not like you can actually go about creating these indexes later down the line, because create indexes statement is actually not supported for memory optimized tables. So all the indexes that you want to have on your memory optimized tables have to be defined during the create table statement itself, right? Also, memory optimized indexes exist only in memory. So again, that's a big improvement, because you do not need that amount of storage space for your indexes on your hard drives. And since these index structures are not persisted to the disk, they are also not logged in the transaction log, right? So there is no need to kind of or I should say, since these index operations are not getting logged, right? Your transaction log problem is also reduced significantly with these memory optimized tables. Essentially, all the memory optimized indexes are covering indexes, and all the columns are included in the index itself, right? So it's and also it's also very important for you to know that memory optimized tables can only support a maximum of 8 indexes, right? So you cannot have more than 8 indexes defined on a particular table which is memory optimized. So there is a good article towards the guidelines for using indexes on memory optimized tables. It's a good MSDN article available on the internet. Probably you can just search it on, and it's good to read actually. Very informative. Right. Now, next is the AMR tool. So, SQL Server Management Studio, right, includes the AMR tool, which kind of gives you certain recommendations as to what tables or stored procedures should be considered for migration to in-memory OLTP. So, if you have your existing environment and you are not sure as to what are the objects, when I say objects, I'm referring to the disk-based tables. So what are your current disk-based tables that need to be migrated to in-memory OLTP? If you do not have an idea about that, there is a tool that is provisioned along with SQL 2014 Management Studio called the AMR tool. AMR is the acronym for Analysis, Migration, and Reporting, right? And it allows you to analyze and evaluate your existing OLTP workload to determine if your in-memory OLTP will be able to improve the performance or not, right? Now, based on this analysis and evaluation, AMR is going to provide you with certain recommendations about the tables and stored procedures who are potential good candidates of migration to in-memory OLTP, right? Now, after you have identified a table or stored procedure that you would like to migrate to in-memory OLTP, you can actually go about using the Memory Optimization Advisor to help you migrate your traditional disk-based tables to the in-memory OLTP, or I should say in-memory OLTP, memory optimized tables, right? So what we recommend is we recommend you to run the AMR tool for at least an hour or so and capture your performance baselines. Now, the longer you run your tool, the more representative your captured statistics are likely to be, right? So we request you to kind of go about using this AMR tool for monitoring the performance, and it creates certain SQL jobs that collects data from the server every 15 minutes. It stores that data into a data warehouse, right, or into a particular database in 2 different collections called the table usage analysis and the stored procedure analysis. So we are going to take a look on it in a short while. All right, so time for us to dive into a demo around the in-memory OLTP. Okay, so let me just bring up my slide. Okay, I think it's visible to all of you, right? So this is a virtual machine that I've created, and there is an instance of SQL Server 2014 that is installed, right? Now, just to give you an idea about the background as to what we are going to do, right? I have a AdventureBooks 2014 database, all right? Now, if I expand this database, I just have one disk-based table called sales order detail, all right? You just need to pay a little bit of attention on this, because if you miss out on any of the points, I think it might get a little difficult for you to understand or to follow through, right? So kind of just bear with me. So this sales order detail table is populated with about 2 million records, right? So as I said, this is the only table that exists within this database, right? Now let me pull up a quick script over here. Right. Now, as I said, when you want to kind of have some of your tables, migrated from traditional disk-based tables to in-memory tables, right? There's something that you need to do as a prerequisite. First thing is you need to add a particular file group that would be holding the metadata for your memory optimized data, right? So if you see, I just have this database and I just have one disk-based table over here. And now that I want to create some in-memory tables in this database, I'll have to add a file group. It could be any name that you may want to give, right? And you should say it contains memory optimized data, right? So I'll go ahead and add this. All right. Next, I will say auto database name. I'll have to add a file to this particular file group to be able to hold all that data, right? So I'm going to add a file. You can see the part defined, and to the file group which we just created, which is the memory file group, right, in the previous step. So I'm going to create this file as well. Great. Now next, what I'm going to do is I'm going to define an in-memory table. Okay, so if you see the syntax, I'm going to create a table, and I'll give all the column names, and I'll give a primary key non-clustered hash index with a definite bucket count, right? And I'll say with memory optimized on and durability equal to schema and data, right? I'm going to execute this. Okay, so if I refresh, I have two tables now, one disk-based table and one memory optimized table. In the next step, I'm going to create another in-memory table, okay, which is a copy of the first in-memory table that we created. So the schema is same, right? Next, what I'm going to do is refresh this. So I have a memory source and a memory table. Next, what I'm doing is I'm populating my sales order detail memory source table from the sales order detail table, right, which was the first table that we already had in the database, and I'm going to populate all my data into my memory optimized table. Right, so this will populate all my data from my sales order detail table into my sales order detail memory source table. Since we are dealing with a lot of records, this might take a little while. Okay, this executed perfectly fine. Next, what I'm going to do is I'm going to create a procedure, a natively compiled Swift procedure. Okay, so create procedure. I'm not going to, since we are running out of time, I'm not going to discuss a lot about the syntax, but just to give you, you know, a few things to note in the syntax is that you need to mention with native compilation and begin atomic with transaction isolation level equal to snapshot and language equal to English, right? So some of these things are mandatory. So I'm going to create this natively compiled stored procedure and execute. Now you need to make sure or you need to understand that since this is a natively compiled stored procedure, it can only operate on memory optimized tables. So if you see the definition of this stored procedure or what this stored procedure does is that it deletes from the sales order detail memory table and it then inserts the data into the same table from the sales order memory source table, right? So it's kind of a resource intensive or transaction intensive stored procedure, I should say. Next, I'm going to create another disk-based table, right, which is a replica of my sales order detail table. So if I were to give you the entire background, we have 2 memory optimized tables and 2 disk-based tables, right? And one of the disk-based tables is empty, and this one has 2 million records, and sales order detail underscore memory is again empty, and memory source again has 2 million records, which we populated from sales order detail table, right? Next, I'm going to create a regular stored procedure, right, which would be operating only on my disk-based tables. Nothing fancy about this. It's a normal stored procedure. Again, it is deleting from one of the disk-based tables and again repopulating it from the second disk-based table. Right now, as you see, since we have created 3 objects as in memory OLTP, right? 2 of these tables and another one for my natively compiled stored procedure. So if I can go ahead and check the DLL information about all the objects that are there in this database. So these are the 3 DLLs, right? And this is where they are actually stored. Okay. So you can use these sysdmos loaded modules, DMB, to kind of go about querying the data about, I should say, querying the metadata about your in-memory objects. Right. So now once we're done with this, I think we are pretty much done, and let's see like how do we test the performance benefit. Right. So I'll open up another script. So what I'm doing over here is I'm going to run these stored procedures that we created. Right. One of these stored procedure is for the disk-based tables. It only operates on the disk-based tables, and another one is is for the memory optimized tables, right? As in the natively compiled stored procedure. So we are dealing with the same amount of data, right? It is just that it differentiates with the kind of tables they are, right? So this stored procedure is kind of again deleting data from one of the disk tables and repopulating it from another table, which is again disk-based table. And in this particular transaction or in this particular stored procedure, we are just dealing with memory optimized tables, and they are again doing the same thing, right? So I'll go ahead and execute this, and I have put it in an explicit transactions, right? So just to make sure and just to show you like what is the kind of logs that are held, right? When we are executing, or when we are dealing with these tables. So I say begin tran, and I execute the select table destination disk table. So what this will do is that it will delete all the records from the sales order detail table and then repopulate it from the other table. So these are the 2 tables that we are dealing with right now with this stored procedure, right? So okay. So it took almost 22 seconds. On the bottom right corner, you can see the amount of time it took, right? And since this transaction is still open because this was an explicit transaction, so we have not yet committed or rolled it back. So if I see the kind of locks that are held on these tables, you can see that there are exclusive locks taken, right? Because these are traditional disk-based tables. So to ensure that we are transactionally consistent, it has to hold these exclusive locks, right? So I'll go ahead and commit this for now. Okay. Now what I'm doing is I'm again going to execute another procedure, which is my natively compiled stored procedure, and this would only work on my memory optimized table, right? So you can see that this just completed in a span of 2 seconds, right? So the same amount of data, same kind of transactions took 22 seconds to complete, right? Now, just to let you know, this is a lab machine. There is no intensive workload going on, hence you do not see a lot of transaction times, right? But typically, if you test these things in a production environment, or if you check the performance in a production environment, this is a serious impact that you can make on your response times for your queries, right? So it just took 2 seconds to complete, and if I check the logs, because as I said, I executed this again as a part of an explicit transaction. So if I check the logs over here, you can see that there are shared logs taken, but there are no exclusive logs taken in this case, right? So it's pretty much a lock and a latch-free environment that we are working on right now if we are operating upon the memory optimized tables. All right. Great. So this is the kind of performance improvement that you can expect when you work with memory optimized tables. Now, as I said, there is an AMR tool as well. So I don't think so we have sufficient amount of time left, but I'll quickly run you through what it is all about. So your AMR tool basically uses the data collector mechanism, which has been there since previous versions of SQL Server, right? So all you need to do is you need to go to data collection, go to tasks, and you need to configure a management data warehouse, right? I already have a database created on my server. If not, you can go ahead and create a new database server, a new database, and assign the right permissions, hit next and say finish. So this configures the management data warehouse. Again, I need to configure the data collection. So basically, for those of you who do not have an idea about data collection, what it does is it kind of extracts the usage and the performance analysis on a particular server and stores all that information into a database that is MDW in this particular case, right? You can also configure data collection sets remotely, right? It is just that you need to use a SQL Server agent proxy for remote uploads. So with 2014, you also see an option for transaction performance collection. So you need to check both of these options, hit next, connect to the server, and say finish. So this, what it does is it basically goes ahead and it creates certain data collection jobs which execute every 15 seconds, and they upload the metadata about your queries, about your stored procedures, about your tables, what is their usage. All of that analysis is stored into numbers into the data warehouse database, right? So if you see, there are certain jobs that get created as a part of collection and upload, right? Now, how do you go about analyzing it? Right click on the data, on the management data warehouse or whatever database that you uploaded all that information. Go to reports, management data warehouse reports, and click on transaction performance analysis overview, right? It gives you table analysis, it gives you stored procedure analysis. So what is the usage analysis, right? So if you see significant migration work, so this basically tells you how much amount of migration work you need to carry out to be able to migrate a particular database object to in-memory or to a memory optimized table, right? And what is the kind of performance gain that you might get. So that is kind of reflected on the y-axis, and on the x-axis it kind of shows you the amount of work that needs to be done. So logically, anything that falls into this particular quadrant, right, is kind of eligible, or the most eligible candidate for an in-memory OLTP, right? Similarly, this was on the usage analysis. Based on the contention, it again offers you certain details. Now, it does not give you a lot of information on my server because this is just a lab machine. I do not have some intensive workloads running on, but if you kind of create these or configure this management data warehouse at your end, right, this data collection at your end on your production server, you will definitely, and allow it to run for some time, you will definitely see some results out here, right, which are the potential candidates. Also, for the stored procedure analysis, it again gives you the details which are eligible, right? So I was just testing out with some queries, and test one is the most eligible candidate to be able to convert it into a natively compiled stored procedure. Also, in addition to this, it offers you the capability to do it. So all you need to do is you need to go to that respective table which is suggested by the transaction performance analysis overview, or by this data collection tool, by the MR tool. Let's say if it was sales order detail, what you need to do is right click on the table and go to memory optimization advisor. Once you click on that, it opens up a wizard, right, and it shows you like what are the potential issues, right, if at all you want to move this table to a memory optimized table, right. Now as you can see, there are certain failures, right, or certain things which are not supported. As a result, it shows a red cross, right. So I need to take care of each of these red crosses to be able to kind of move this table to an in-memory OLTP table. Now, before this, let me move back to this deck. Sorry. So there are certain limitations and restrictions as well with the in-memory OLTP. So there are certain data types which are not supported by memory optimized tables as of now. Just to name a few of them are like text, varchar max, user-defined data types, XML, image, and text. So these are certain data types which are not supported. Also, there are certain database features which are not supported, like let's say database mirroring is not supported for these tables. Then DBCC check DB, DBCC check table, all of these commands don't work, right? Triggers are not supported, identity columns are not supported. So there are certain limitations and restrictions as of now, but definitely the product teams are working on this, and you will see that these limitations and restrictions are taken off in the future with future releases of SQL. All right. So with that, I'm more or less done on this particular feature, right? If you have any questions, we are there for you for the next 5 or 10 minutes. Feel free to use the Q&A panel, and I'll be more than happy to help.
Thanks for the insightful presentation, Amit. Let's quickly take up the questions now. Just like you have mentioned, I request you to read out the questions and their answers so that all our users may listen to your insights. Are you able to see the questions coming into you?
Yes, definitely. I'll take it up. Right, so the first question is how is it different from DBCC pin table, right? So this is definitely very different from DBCC pin table. DBCC pin table just ensures that your table resides, your table structure resides in memory, right? But underneath it definitely has a copy onto the disk. So every time you carry any DML operation on the table, it has to kind of fetch back the page from the memory and modify it, and then move that data page or move that change back to the disk whenever a checkpoint occurs, right? So all that is there, but within memory OLTP, it is totally a memory resident data. So you don't have to work out of the box, and SQL Server does not have to work out of the box the way it has been doing in the past, and it kind of just carries out those changes then and there in the in-memory data, right? And as I said, it has got a a file stream, a file group wherein a file resides. So if it has to do a recovery, right, from an abrupt shutdown or something, it uses the transaction log and uh, the file stream file group to be able to catch up with all the changes that were not reflected. There is a question about does this support OODB? I'm not really sure what does this, what are you exactly referring to? Probably if you can shed some more light on this, I can take it up. Now, what is next question is, what is non-clustered hash index? How is it different from the normal non-clustered index? So as I said, the normal non-clustered index is actually built up using a B-tree structure, right? If you might be aware of if you might be aware about this, right? So it uses a B-tree structure to kind of go through the entire records. But if you talk about the non-clustered hash index, it is a memory resident index. It is very different from the traditional index. It does not use the B-tree structure to kind of store the rows, and it is actually, it uses memory pointers to be able to go to the right data set. Right, so if you have, there is a next question, is it possible to restore the backup of an in-memory database from one server to another server? And are there any limitations with the edition? Definitely there are limitations, as in this is an enterprise edition only feature. So to be able to use this feature, you will have to be on SQL Server 2014 Enterprise Edition, right? And you can definitely go about restoring the backups of a database that contains in-memory tables, but you need to make sure that you are only restoring them on a 2014 version of SQL, and that too on an enterprise edition, else it won't support. So next question is, all of a sudden we have a power drop. What happens to the memory table transactions, right? So again, the logging mechanism remains same, right? So when we're talking about memory optimized tables, there are just certain tables that that their data will be residing in memory, but the logging mechanism is the same that we have had, right? Just to ensure that the transactions are durable and they're consistent, everything gets logged into the log file, right? So if at all there is a power drop, the recovery and the logging, right? It's all done using the transaction log and the file that it created into the respective file group. Next question is, what is the maximum limit on the in-memory size schema? So as of now, you cannot have any table more than 512 GB. But again, we do not recommend to have a 500 GB table as in-memory table, because you need to make sure that you leave certain buffer memory for your multi-version, your optimistic multi-version concurrency control as well, because every time you do an update, there is a parallel copy of that row that is preserved, right? So if at all you have about a 500 gigs table, you need to, or sorry, if I were to put it in other words, I should say that do not move any tables to in-memory table unless it is, like, let's say, more than 256 or 300 GB for now, right?
Due to time constraint, I have to request you to take the unanswered questions offline, which I will share with you through email. So if you would
Sure.
like to sum up the session for today, you can do it now.
Sure. I think Radhana, there's just one more question that is left. So I think I'll answer it right here. So the next question is, as I said, it doesn't support database mirroring, right? So all the tables which is of in-memory table will not be mirrored. Yeah. So see, mirroring is a database level feature, right? So you enable mirroring at the database level. When we talk about memory optimized tables, that is something that is done at the table level, right? So any database that has a memory optimized table defined under it, you will not be able to mirror it, right? It will give you an exception if you try to mirror it on other server. I hope that answers your question, Rakesh.
So if you would like to
All right, so
sum
with
up the
that,
session, you can do it now. Yes, please go ahead,
yeah,
Amit.
absolutely. Yeah. So yeah, so I think that was it from my end. And if you have any questions, feel free to just put it on the TechGig portal, and we'll take it up.
I'm
Thank
really
you. Thanks
thankful
for
to us.
attending.
Yes, and I'm really thankful to our guest speaker today for conducting this wonderful webinar. It was indeed a great session. I would also like to thank all our participants for their support in making this webinar a success. The recording of the webinar will be available on techgig.com by tomorrow. Thank you all for joining us today. Thank you, Amit, for taking the time out and having us. I hope you have a great evening ahead.
Absolutely. Thanks. Thanks, Another for all your support.
Thanks a lot. Bye-bye.
Bye.